Currently, we are facing a health crisis which is affecting around 40% of the world's population, especially in US and India. And some estimates suggest that around 80% of the people show the initial symptoms for it. In fact, today the leading cause of death is because of this particular condition. The condition I'm talking about is metabolic syndrome, and in this video we're gonna go deeper into the science of it and how we can tackle it for our better health. Hello guys, my name is Amar and I have a PhD in structural biology. I have about 10 years of experience in performing independent research and reading scientific papers. So recently I realized that I too was going in this direction towards developing this syndrome. So I did what I do the best, which is I dwelled into the science to understand it better. After discussing about this, about the learning that I had with my friends, they encouraged me to make a video out of it. This is one of the first video of its kind where I explain scientific concepts of everyday relevance to people in simple language. So stay till the end where I explain how I use the learnings that I got from this personal research to get my health back on the track. So one disclaimer, although I might be called a doctor, I'm not a kind of doctor who saves lives. So consider this video as an infotainment and please do your own research too. So what is metabolic syndrome and why is it important to learn about it? Well, it's a cluster of conditions which, if present, causes heart attack, stroke, or type 2 diabetes, which, as we know, are a major problem right now that the world faces. So there are 5 criteria which could be considered as a symptom for metabolic syndrome: high blood glucose level after fasting, high triglyceride, high LDL cholesterol, high blood pressure, and higher amount of fat near waistline. So that last criteria itself tells you that this might be more prevalent than we might think about, as we can see that people who have pot belly might be probably also going through the condition. So you might be thinking these are very different conditions. The high blood pressure is caused through salt, as you all know, and high fasting blood glucose is caused due to sugar. But these are all related to each other, and we are looking at different parts of the same metaphorical elephant. And that metaphorical elephant is insulin resistance. So in this video, I want to dedicate and go through each of these criteria and how insulin resistance is actually causing them. Remember, knowledge is power, especially when it comes to health. And I think just being aware of these things and the science behind it might help us even more to live a healthy life. Before we understand insulin resistance, it is important for us to understand what is insulin. Insulin is a molecule which body produces, and one of its main function is to transport glucose from the blood into the cells. Cells need glucose to burn them to create energy, but the glucose cannot just enter into the cell. It needs to have this insulin which acts as a seat on which it sits, and the cells have receptors which are like hooks which attaches itself to the insulin, and thus the insulin which is attached to these receptors is able to allow the glucose to enter into the cell. Now, when we say insulin resistant, that means the body needs more amount of insulin present in the blood to do the same amount of work it did before. And what is this insulin resistance? Well, if you can think about, like, when you enter into the room which has a particular foul smell, you can sense this for initial 5-10 minutes, but slowly your body or your brain gets used to it and you stop sensing it. In the same way, body has this tendency, or the cells in the body have the tendency, where if it is exposed to a lot of insulin for a long period of time, it starts numbing itself to the effect of insulin around it. So this is called as insulin resistance, and this is the crux of the different criteria that I mentioned before. And I'm going to go in detail about how exactly this insulin resistance is creating each of those 5 criteria, and thus the body is facing metabolic syndrome, which ultimately causes serious diseases. So the connection between insulin resistance and high blood glucose, or it's called as hyperglycemia, is easiest to explain because it is direct. So what happens is that when you eat food, your intestine or gut absorbs glucose from it and it enters into the bloodstream. Now, as I mentioned, insulin is used to shuttle the glucose into the cell. Anytime that the body experiences that there is more glucose present in the blood, it releases insulin. This insulin is released by pancreas. Now, if there is more glucose that is absorbed because we drank Coke or something, then more insulin is released by pancreas. But as I mentioned before, if there is consistently high level of insulin present in the body starts developing resistance. So what happens is now the body needs more insulin to do the same amount of job. So that means pancreas would release more insulin. And this will create a feedback loop where higher amount of insulin would make the body more resistant, which will make the pancreas to release more insulin. This keeps on going till a point is reached where the pancreas stop working efficiently because they are literally tired, and this is called as an onset of type 2 diabetes. So one of the treatment that doctors suggest in this case is injecting insulin into the body. Now this might come as counterintuitive. Wasn't the insulin resistance caused by higher amount of insulin already in the body? And that's true. Adding insulin externally doesn't actually solve the problem. It doesn't cure you from the type 2 diabetes, but it's very essential to push this glucose into the cell once it's already in the blood. Why? Think about when a Coke spills on your desk, right? If you touch that solution, which has high amount of sugar in it, it feels sticky. That's because glucose has this tendency of sticking to the biological molecules. So if it is circulating for a long period of time in the blood, it's not good for the internal organs or the inside of the veins, because it tends to stick to those veins, and that's detrimental for the body. And it doesn't just stick to the organs, but it also sticks to the molecules that is circulating in the blood. In fact, one of the major molecule that is there in the blood, which is hemoglobin, glucose sticks to the hemoglobin too. And this property is in fact used to diagnose the average amount of blood glucose that a particular patient is exposed to for the last 3 months, because that is about the average amount of time a hemoglobin molecule circulates in the blood. So body always tries to increase more amount of insulin to shove this glucose inside the cell. If it's not possible, then we treat it by adding more insulin into the body. So diabetes essentially is not a high blood glucose problem. Diabetes is essentially excess insulin problem. And even though we add more insulin to the body, it's just a temporary relief of reducing the glucose, and the actual way to treat diabetes is only by treating the underlying insulin resistance. Now, this high blood cholesterol or high amount of bad cholesterol called as LDL is the most researched criteria among these 5. This is because when a person dies because of metabolic syndrome, most of the time it's because of the heart attack, and it's directly caused by this bad cholesterol. Heart attack is primarily caused because the artery which provides blood to the heart gets clogged because cholesterol starts accumulating in that artery, which pinches it and the blood cannot pass through it. Now, the science behind why that happens is complicated because there are a lot of interacting factors, but it's very essential to understand it, so I'll try to explain it in simple words. To understand it, first we need to understand what is a cholesterol. Cholesterol is not a bad molecule, first of all, and second, cholesterol that you eat from food is not absorbed by the body. Body makes its own cholesterol. So when there is food which says that it's low in cholesterol, it's usually nonsense. Now, why is cholesterol important? Cholesterol is a precursor molecule that the body uses to make other molecules which are also important for the body. But one drawback of cholesterol is that it is not soluble in water. What that means is that it's not going to be soluble in the blood. So if your liver makes cholesterol and if it needs to transfer it to some different cell, it needs to do it through blood, but it doesn't dissolve in blood. So what happens is liver also makes another molecule which is called as lipoprotein, which acts as an envelope around these cholesterol molecules, and then this envelope is now soluble in the blood, and it can go and transfer its content to the cell at a distant places. Now, primarily, to make it simple, there are two kinds of lipoproteins. Low density lipoproteins, which are called as low density because it is filled with cholesterol, and cholesterol being lighter than water, that molecule becomes low density molecule. That's a very crude way to explain it. And there is something called as high density molecule, which means that it has low amount of cholesterol. Now, low density lipoproteins are used to send the cholesterol to different parts in the body, and high density lipoprotein, because they have less amount of cholesterol, can absorb more cholesterol. So it goes and scavenges the random leaks that LDL has produced in the body, and it absorbs the cholesterol from it and brings it back to liver. And LDL particles which are not unloaded also goes back to the liver, which is then absorbed by the liver. This is an important point to understand, that LDL particles which are not used by the cells also goes back into the liver and they are reabsorbed. Now, sometimes inside the veins, the layer inside the vein gets damaged, in the sense that there are cuts which are formed, and these are formed due to inflammation. One of the most primary cause of inflammation is smoking, but it can also be caused due to diabetes, and it can also be caused due to even high cholesterol itself. Now, when these cuts are formed, it becomes a space such that this low density lipoproteins can actually enter inside this cut and can lodge itself below this inner surface of the arteries. Sometimes these cholesterols which are lodged inside the arteries can be scavenged back by the good HDL cholesterol, right? It can absorb back the cholesterol and take it back to liver. But if this cholesterol stays in the vein for longer period of time, again due to inflammations, these cholesterols can get oxidized. Now it's a very different molecule, and this molecule cannot be readily scavenged by the HDL and brought back to the liver. So they start accumulating. If anywhere in the body, if a body experiences some alien material, it is going to send its immune cells to bring it out from that place. And it does the same. It sends macrophages, which are like big eaters, which eats away the stuff that cell body doesn't want. It sends this macrophages, and this macrophages goes and starts eating off this oxidized cholesterol, which has been lodged in by LDL particles. But the problem is, after eating away these cholesterol molecules, they stay in that location. So if you have more oxidized cholesterol present lodged under your arteries, more amount of macrophage is going to come, eat them, and just stay there. This is something which is called as plaque, and they start accumulating in that location, and it start pinching that artery's inner wall to the point that at one point it just stops the blood flow. Once the blood flow is stopped, the heart doesn't receive the blood flow from that particular artery and malfunctions, and it can lead to heart attack. So you can see a lot of different things are happening at the same time. You get cuts in the inner wall of the arteries, which is caused by inflammation, and also maybe due to smoking primarily. You also have high amount of LDL particles that are now present, and they are present in the higher amount because the body is not readily absorbing it. And you also have low amount of HDL particles that are present, so it's not able to take back those cholesterol which has been lodged by the LDL particles, which gets oxidized again due to inflammation. Now, where is the insulin coming into this picture? As I mentioned before, the LDL particles need to be reduced, and they are reduced by liver reabsorbing them. If the body is insulin resistant, liver loses the ability to take these LDL particles back. So in a way, the primary cause of the heart attack, which is the buildup of the plaque, is by the supply of cholesterol from LDL particles, is in a way facilitated because the body now allows more amount of LDL particles to flow in the blood because now it's insulin resistant. So even here, the primary cause is insulin resistance. The relation between chronically high blood pressure and insulin resistance is most indirect. Now, having high blood pressure is not a bad thing. You can have momentarily, you can have your blood pressure increase because you just ate some salty food, or you just had some exercise, or you're really angry at that moment. The problem arises if the blood pressure remains elevated for a really long period of time. Most of the time, the blood pressure increases due to high salt content in the blood. Now this is a very well-known physical phenomenon where if you have more salt concentration in a particular region, water moves from low salt concentration to high salt concentration. So in this case, if the arteries have high salt concentration, then the water is going to move from the body inside the arteries, and then this is going to swell the arteries, and we can say that the arteries are experiencing high blood pressure. This is fine. The problem arises if this blood pressure remains high for a really long period of time. That can happen in two ways. One, if you keep on consuming high salt food continuously, which can happen. That's why we say that this high salt consumption leads to high blood pressure. But the other way, and which is more common, is when the body loses its ability to remove the salt consistently. And that happens because the kidneys, whose one of its main job is to remove the salt, starts functioning subpar. And this is one of the way in which this is caused is through insulin resistance. If the body has developed insulin resistance, the kidneys don't work as they worked before, and they lose their ability to some level to remove this salt consistently, and thus the salt remain higher in the blood, which then leads to high blood pressure. Now, so then the question arises, was it the high salt concentration which caused the chronically high blood pressure, or is it the insulin resistance? To understand this, we can think about an analogy where a plane is flying and suddenly one of its turbines stops working and the plane crashes. Sorry for this morbid example, but everybody on the plane dies because of the fire. Now you can say that the fuel is the actual reason why the people died, or you could say that the turbine stopped working and because of that the plane crashed, and that led to the fuel getting ignited. So in this particular example, the fuel is the salt, high salt concentration, but the turbine malfunction is the insulin resistance. So if you consistently consume more carbohydrates or sugar, you will develop insulin resistance, and then high salty food, high amount of salty food will actually create more problem, because now your body is less tolerant to high salt concentration. So even over here, insulin resistance is the major reason for high blood pressure chronically. Now, as I mentioned before, the excess amount of sugar that is consumed, which the body doesn't instantly burn, that is converted into fat by liver. Now, there are two kinds of fat based on where they are stored. A fat which is stored anywhere in the body, just below the skin, is called a subcutaneous fat, and it's usually considered as good fat, because the other kind of fat is actually a bad fat, which is called as a visceral fat. Visceral fat is the fat which is not present just under the skin, but it is located between the organs in our abdomen. Now that's the place where the body is not supposed to store fat, but these days, because we consume a lot more calories compared to our species about 10,000 years ago, the body starts storing this fat in weird places, which is between organs. Now, one of the places where the body stores is where it is generated, liver itself. A liver which is covered with fat is called as a fatty liver, and fatty liver is a sick liver. In fact, if there is a lot of fat which is deposited on the liver due to excess consumption of sugar, then it's called as fatty liver, non-alcoholic fatty liver disease. It's called as non-alcoholic fatty liver disease because it is essentially the same thing that is caused when you consume a lot of alcohol. So yes, sugar consumption leads to same deterioration of liver as excess alcohol does if we consume a lot of sugar. That's a different topic to discuss. Now it's called as a fatty liver disease because the liver, as I mentioned, doesn't work well, and it shows the same symptoms that a body shows when it is insulin resistant. So now you have a lot of fat getting accumulated in that region, and that's why the body starts bulging from around the tummy. When there is a lot of bulge around the tummy, that means that there is a lot of visceral fat. That means there is very high chance that the liver has a lot of fat on it, and that is a sick state. So one of the indication for metabolic syndrome is also a larger waist to hip ratio. Since we mentioned that the visceral fat is the actual fat which could cause problem, what that means is that not all overweight people tend to have metabolic syndrome, and just because somebody is skinny doesn't mean that they don't have it. A big part of that equation is how much fat you have around the abdomen region, because that fat is primarily caused by overconsumption of sugar or carbohydrates. I might have gone a lot more detail in some things, but at the same time I have also oversimplified many of the concepts to make it more available to all the audience. But the central point that I was trying to make is that all of these symptoms are in some way or other caused by insulin resistance. The thing about insulin resistance is that it takes a long period of time of having high amount of insulin in the blood for the body to develop the insulin resistance. So the insulin resistance happens much before any of these symptoms show up. So you might be thinking, why does the body has this bug? As in, why something as important as insulin goes off the chart and creates so much havoc in the body? And the reason is that our body has been evolved for a very different environment, which was about tens of thousands of years ago, where humans lived a nomadic life. Now, in that kind of environment, the carbs were not very readily available. For example, the best source of carb you would think about would be fruits from trees, but even those were very different fruits from what we eat today, because they have been changed or they have been hybridized for making them more palatable. Eating fruit is not considered unhealthy, because although it has an apple has same amount of sugar as a Coke, but apple has a lot of fiber, and nature always does this. If you go and look around, let's say sugar cane from which we get the sugar, you can see how much fiber the nature has packed in. It's almost like a bamboo stick. So in prehistoric time, we were not exposed to most of the food that we are consuming right now. Definitely not sliced bread. The thing is, insulin rises in reaction to blood glucose, and what that means is that insulin spike happens almost always due to consumption of carbs. And I have experimented that myself. I have attached a CGM device which can measure the amount of blood glucose in real time, and I noticed that it's, of course, I didn't consume any sugar during that point, but I noticed large spikes even with consumption of potatoes in terms of pav bhaji or rice or refined flour like bread, and those spikes were pretty similar to the spikes that I had once when I had Coke. In fact, juices especially are as bad as a Coke. They are not natural. A glass of juice has about 3 oranges worth of juice in it, and try to recall when was the last time you had like 3 oranges at one sitting. And even if you did have it, you still had fibers, which allows the body to absorb the sugar slowly, which allows the spike to be not rapid. The other thing that worked for me was I didn't do a intermittent fasting for the whole time, but once a week at least I ate only once, and I allowed a prolonged period of time where I didn't consume anything, almost 22 hours. And what it does is that since there is no glucose that is being, well, the glucose is always flowing a little bit from your body, but since you do not have spikes in glucose because you didn't consume anything, the body gets used to a lower average concentration of insulin circulating, and which should over the time lead to more insulin sensitivity, which is the main way to fight all of the above symptoms that I mentioned and the metabolic syndrome as a whole. So as I mentioned before, I too faced some off values in my blood report, and as I promised, I'm going to discuss that before I end this video. So in about September 2021, I saw that my TG values were very high. As you can see over here, almost 222 mg per dl, which is much higher than the normal that is expected, which is about 150. So when I got this, my medical provider suggested that I eliminate dairy and also cut down on sugar. So I did have some sugar, I did cut it down a little bit, but the main thing I did was I eliminated the dairy. And as you can see, in October 2022, about 1 year later, I could see it go down. But then continuing with non-dairy, I still had it go up to about 195 again, right, in about January 5th, 2023. Upon seeing that my TG values are going back again, this time I resumed dairy at the start of last year, 2023, but then cut down on sugar a lot more. You can see over here that in September 6, 2023, I had this come down again, my triglycerides. And then this motivated me that clearly cutting down sugar works. So then I also cut down simple carbs. And as you can see here, in November 28th, 2023, last year, my TG levels went below 196, and this was achieved by eliminating sugar completely in those 3 months. Along with that, or at least reducing as much as I could the simple starch like rice. So summarizing my reports, from September 2021 to January 2023, I reduced my dairy intake. But from January 2023 to November 2023, I reduced my sugar intake, especially between September to November. I eliminated the sugar and simple carbs. What we are seeing here is not very surprising scientifically. Anytime that we consume sugar more than what we need to burn, that excess sugar is converted into fat. This is done by liver by the process known as de novo lipogenesis, means new fat generation. This fat that is generated by liver is then transported to different locations in the body, and this mode of transport is done in the form of TG. So if you consume high sugar, you will obviously have high TG running in your blood. However, there is something to consider that although my TG levels were not very high to start with itself, but definitely elimination of the sugar led to better values. But if in case somebody has really high values, then maybe dietary change itself will not provide the change that we need. So guys, that was the end. Thank you so much if you have stayed till this point. After listening to this a million times, I'm finally get to say this, but subscribe and like. I hope to make more videos like this and get better at this. I understand that this was pretty long video. I'll try to make shorter and more impactful videos if possible in future. Thank you so much.